Dear students, welcome back to the channel. Today we are continuing with the chapter 1, Real Numbers. Today's our subtopic is Analytical Proof of Irrational Numbers. Analytical Proof of Irrational Numbers. In that, there are two types of irrationals we are discussing. One is pure surd, other is mixed surds. Pure means only root 2, root 3, root 5, root 7 like numbers. And the second is a root will be there, along with that whole number or fractions will be joined. Okay, let's discuss in detail about it. Before going to the proof, we should know one theorem. Okay, that theorem we will discuss through examples. For example, 6 is a number. What are the prime factors of 6? We know 6 prime factors are 2 and 3. If you take 6 square, 6 square contains 2 square and 3 square. So what you can understand from this is 6 contains the prime factors 2 and 3. 6 square also contains the prime factors 2 and 3. Be careful, it is only about prime factors. 6 contains the prime factors 2 and 3. 6 square also contains the prime factors 2 and 3, but 2 not 1, it is in square, or 2 times 2 and 2 times 3 are here. So whatever prime numbers are present in the number, the same prime numbers are present in the square number also. So we can say 6 is divisible by the prime numbers 2 and 3. 6 square is also divisible by the prime numbers 2 and 3. So with which prime numbers you can divide 6? With the same prime numbers you can divide 6 square also, or we can say the opposite. With which prime numbers you can divide 6 square? With the same prime numbers you can divide 6 also. But if you take a composite number, okay, composite number like 18, okay, 6 square means 36. This 36 is divisible by 18. It is true. But with this composite number, you cannot divide 6. You can divide 18 by 6, but 6 cannot be divisible by 18. So composite number, this rule sometimes correct, sometimes not correct. So if it is perfectly correct, then only it will become a theorem. Okay, so with which prime numbers we can divide a number? With the same prime numbers we can divide its square also, or its converse. If a square number is divisible by some prime numbers, then the base number is also divisible by the same prime numbers. Clear? Okay, let's take another example. 10 contains the prime factors 2 and 5. 10 square contains 2 square and 5 square. Here 10 square is divisible by both 2 and 5. 10 also divisible by 2 and 5. Understood? So this goes to a theorem. If P is a prime number, if P is a prime number such that P divides A square, then P divides A also. P divides A also, where A is a positive natural number. So here this statement says, this statement, why we took this statement is useful to prove pure surds. Okay, during the process of proof of root 3, root 2, root 3, root 5, we can see this rule is applied. Okay, let's prove, okay, this is a board exam question also, prove that root 2 is an irrational number. Root 2 is an irrational number. So how do we start the proof? We are doing with contradiction method. This is little bit different from the normal method. Suppose, what is the meaning of contradiction method? Suppose what we have to prove, its opposite we have to assume. To the contrary, contrary means what we have to prove, its opposite we are assuming root 2 be rational. We assume that root 2 is an irrational. Say what is its name. Let the name of root 2 be a by b. Rational numbers form is this, a by b, where a and b are coprimes, comma b is not equal to 0. What is the meaning of coprime? Okay, let's take one fraction like this, 10 upon 3rd. What we do if you get a fraction like this, we will simplify it first and we write 5 by 6. This simplified form, in this simplified form, we cannot further divide 5 and 6. They are only divisible by 1. The numerator and denominator are only divisible by 1, or their HCF is 1, or they are called coprimes. Suppose they have something common, they might have cancelled and it is made into the simplest form. Okay, so we have to write it, and this is everybody has to write and by heart it. Okay, if it is root 3 also, we will write the same statement. Therefore, we can write root 2 is equal to a by b. And then square it. On squaring both sides, we will get root 2 square is 2 is equal to a square by b square. Then cross multiply this. You get 2b square is equal to a square. After reaching this, what you can understand, let this be equation 1. What you can understand, 2 is multiplied with b square. What 2 can do other side of this equation? 2 can divide a square. So we take the divide part which tells 2 divides a square. And just now we studied one statement or theorem that where 2 is a prime number. A prime number 2 divides a square number which tells 2 divides the base also, a also. Have you got it? If 2 is a prime number which divides a square number, then that 2, the prime number divides the base a also. Okay, what does, can you say 2 divides 5? Can you say 2 divides 5? It's a wrong statement. Why? If you divide 5 by 2, you will get something as the remainder, or its decimal form you will get the answer may be 2.5. You should not get decimal quotient. But if this is 2 divides 6, it is correct because 6 is divisible by 2 and the remainder is 0. Okay, we are getting which type of quotient? Integer quotient we are getting. So here it says 2 divides a. That means that is a divided by 2. We can divide a by 2 is an integer c, where c is an integer. C is an integer or a positive integer. Okay, then you cross multiply this, you get a is equal to 2c. A is equal to 2c. Let this be 2, second equation. And then substitute this second in first, in equation first. In equation first, A's place you write this 2c. So the left side of this equation is 2b square is equal to 2c the whole square, which gives 2b square is equal to 4c square. You can cancel out 2 from both sides. You get b square is equal to 2c square. B square is equal to 2c square. What 2 is doing with c square? 2 multiplies with c square. If you shift 2 to the other side, what 2 can do? 2 divides b square. So what we can write here? We can write here 2 divides b square. 2 is a prime number which divides b square, which tells 2 divides b also. 2 divides b also. In first statement we have written, okay, let this be a and this be b. In a we have written a divides a, 2 divides a, and b we have written 2 divides b. Therefore from a and b, 2 divides a and b. But when we started, we have written a and b are co-prime. They are not divisible by any number other than 1. Therefore, that this is a contradiction. This is a contradiction. This is a contradiction to the fact that a and b are co-primes. This contradiction is due to wrong assumption. We have started something wrong. Rest all steps are correct. Only one assumption is wrong due to wrong supposition or assumption. Therefore, root 2 is irrational. Okay, this is the proof of root. Suppose it is root 3, the question is root 3, you have to write here root 3 and here root 3 and square it, it will become 3a square and 3b square. 3 divides a square. 3 is a prime number. You write 3 divides a also, and a divided by 3 is equal to c, and you write here 3c, and here 3b square and 3c square. It will become 3b square here, and this will become 9c square. 3 and 9 will be cancelled and it will become 3. Then you have to write 3 divides b square, so 3 divides b also. Then we write here 3 divides b square, a and b. This is a contradiction to the fact that a and b are co-prime and rest all are same. Like that you can repeat the same question with root 7. Okay, don't do with root 4 because root 4 is 2. It is a rational number only. I hope you got it. Okay, you can try this question in using different numbers like root 2, root 3, root 5, root 7, root 11. Okay, like this. Inside the root put some prime numbers and try. Okay, the next irrational proof is mixed. For example, 5 plus 3 root 2. Okay, prove that is irrational, but in board exam they will be given along with that, given that root 2 is irrational. Given that root 2 is irrational. This will be given in the question. In your textbook it is not given, but in board exam question it will be given. If this is mixed, prove that it is irrational given that root 2 and root part is irrational. Here also we start, this is very easy. His proof is very easy. But contradiction method is used. Suppose to the contrary to what is to prove, we are assuming the given number 5 plus 3 root 2 be rational. We have to actually prove irrational, but we have to start with rational. Say A by B, where A and B are coprimes, comma, denominator is not equal to 0, denominator is here B. Therefore, 5 plus 3 root 2 is A by B. Here there is no need of squaring. Here very simple question like this. 5x plus 7 is 20. How to solve x? When we are solving for x, keep x on the left side, shift all other numbers to the right side. Like that. Here you have to keep root 2 only on the left side, shift everything to the right. Here 3 is multiplied and 5 is added. First we have to shift the added number to the right side. So we get 3 root 2 left out is equal to A by B minus this 5 is added, it goes to the other side as minus 5 by 1. Take the LCM of on the RHS, B and 1 multiply just, B into 1 is B. With 1 you multiply A, it is A. B into 5, it is minus 5B, is 3 root 2. Now you shift this 3 to the right side because it is multiplied, it goes to the other side as divide. Okay, so we get root 2 is equal to A minus 5B by A minus 5B by this 3 goes down, it is 3B. Only this much is required. Only like you are solving for x. Okay, we will do 1 or 2 questions to consolidate the topic. Then here RHS, if you see the RHS, A is an integer, B is an integer, 5 is an integer, 3 is an integer. If you multiply two integers, it is an integer. An integer is subtracted from another integer, so it is an integer. Numerator is an integer. Denominator multiplication of two integers, it is again an integer. So integer by integer is a rational number. Here on RHS, A, 5, B, 3 are integers. Since they are integers, okay, therefore A minus 5B by 3B is rational. Okay, all numbers are integer, so when you multiply two integer, you will get an integer. An integer minus another integer, so this is an integer. Numerator is an integer, denominator is an integer. Integer by integer is called rational. Therefore, this RHS is a rational. Okay, since it is rational, the root 2, that is, if right side is rational, left side is also rational. Root 2 is rational. But it is given in the question that root 2 is irrational, which contradicts the given fact that root 2 is irrational. It is given that root 2 is irrational. Therefore, this is due to every step is correct. Only one step may be wrong, that is the supposition. Rest all steps are correct. Why this wrong answer come? Not because of these steps, only because of the supposition. This is due to wrong supposition or assumption, or our assumption is wrong. Therefore, the given number, what is the given number? 5 plus 3 root 2 is irrational. Okay, this is very common. The last board exam also, in some question papers, it was visible. If the question is like this, 5 by 7 root 7 or root 11. Prove that this is irrational given that root 11 is irrational. Let it be is equal to a by b where a and b are co-primes and b is not equal to 0. Those steps we have to write. And then shift this. 5 is multiplied, it goes to the other side as divide, and 7 is divided, it goes to the other side as multiplied. Then it will change like this, root 11. Okay, this 9 is coming here. Okay, so we write this LHS is, we know it is irrational given in the question, but RHS is rational. So root 11 also become rational. This is a contradiction to the given fact. Like that we have to answer. We will take one negative number example that is confusing us more. 5 minus 7 root 3. Prove that this is irrational. Suppose it is rational, it is equal to a by b. Then shift this 5 to the other side. You get minus 7 root 3 is equal to, here it is plus, it is going to the other side as divide, a by b minus 5 by 1. Then take the LCM here, b and 1's LCM is b, multiply this, multiply a 5 and b minus 5. It is minus 7 root 3. It is multiplied, shift this minus 7 down. Minus 7b it is here. Then you write the RHS is rational. Why it is rational? A is an integer, 5 is an integer, b is an integer. So the numerator is an integer, denominator is also an integer. Integer by integer is called a rational. So root 3 is also rational. This contradicts the fact that, given fact that root 3 is irrational. This contradiction happens because of our wrong assumption that this is rational. We have taken this as rational. Actually this should be irrational. Like this we can. This is the end of this chapter from the textbook point of view. Okay. Prove that, suppose a question is having two irrationals, and prove that this is irrational. So let it be is equal to p by q. Then we cannot shift anything to the right side and do. Okay, for time being you shift one of them to the right side. Root 2 is equal to p by q minus root 2. Root 3 is shifted, so root 3. Then square both sides. When you square this and whole square here, root 2 square is 2 is equal to p square by q square minus 2ab, that is 2 root 3 p by q plus root 3 square is 3. Now you shift all these to the other side, or you shift this to left. Why this is shifted to left? Because it is having root, all others are having no root. Minus 2 root 3 p by q is shifted to left side, it will become 2 root 3 p by q is equal to p square by q square plus 3, and 2 is shifted to right side, it is minus 2. 3 minus 2, it is 1. Take the LCM here, p square, 1 into p square, q square into 1, and q square and 1 is q square plus q square. Then keep this root 3 here, all others you shift to the other side. Root 3 is here, is equal to 2 is going to denominator, so it is 2 q square, and from top p also comes to the denominator, and q goes to the numerator. Numerator is this, so q into p square plus q square. Then you tell the RHS is rational because q is an integer, p is an integer, q is an integer. So this will be a integer by integer, so it is rational, so root 3 is rational, but given that root 3 is irrational, this contradicts. So this way, if 2 irrational comes, you can do it. This is not in the textbook, it may be asked, so I have discussed. So this is the end of this chapter. Hope you all got it. And if you have further doubts, you can send your doubts in the message boxes. Okay. Next class we will start with polynomial.